All right, we are looking today, guys, at z-scores. So a value that shows how many standard deviations, so you should be writing this down with me, standard deviations a data value is from the mean. So a value that shows how many standard deviations a data value is from the mean. When the z-score is positive, the data is above the mean. When the z-score is negative, the data is below the mean. When the z equals zero.
Wait.
Yes, I can totally slow down. A-B-O-V-E. Okay. And when the z-score is at 0, the value is the mean. Okay, now we're going to talk about this equation that you're going to use for the whole week. You're going to need it for everything. You ready?
Yes.
Shh. New equation. You're going to love it because you can just plug things in. Okay. So, X stands for the data value we're going to talk about. This thing, we call this U-shaped thing a mu, stands for the mean. And this little O thing with a like a cursive O almost, it looks like, is the standard deviation. And we're going to find the z-score by X, the data that I'm asking you about, minus the mu, which is the mean, divided by the standard deviation. Okay. So we're just going to plug numbers into that. Okay. Now we're going to try some of these. So we're going to now try plugging things into this equation to find z-scores. So we're going to start. A radar detector records the speeds of a group of cars that pass by. If the mean is 46%, 46 miles per hour, I don't know, I'm real tired, guys, sorry. Time change messed me up. And the standard deviation is 2.8 miles per hour, then the z-score for each value of the data. That's what we're calculating.
So we're finding X.
Okay, no, we have X, we're finding Z.
What's that?
So, it's the z-score.
What is the z-score?
So the z-score is how, wait. The z-score is how far away that number is from the standard deviation. Okay, so we're going to plug it into this equation right here. So, right here, 46, that's the mean, that's that mu. 2.8, that's the standard deviation. And then 52 now is my X. So I'm going to go 52 minus 46 divided by 2.8. Yes.
How'd you get 52?
Because 50, it says A is 52.
Yeah, but is that just
How do you know if
I will give you a number.
Oh, so you have to do it for all three of them.
Okay, so it tells me in my equation, it tells me right here that my mean is 46, right? That my standard deviation is 2.8, and then it says find the z-scores for each data value. So the data value is X.
Oh, so these are options. Those are like problems.
It's not like pick A,
I thought
B.
it was multiple choice.
It's not like pick A, B, or C. It's figure out each one of them.
Oh, okay, all right. I get it.
Okay, so
Yeah, that was weird, but I got it.
there are 3 separate problems here. This is problem A, this is problem B, and this is problem C. So it's not pick A, B, or C. There are 3 different problems. So we're going to go into our calculator. I like to hit Control Divide so the fraction shows up. And then I hit 52 minus 46, move to the bottom, 2.8. And I'm going to get, this is 2.14. So it's 2.14 standard deviations away from the mean. So we remember our empirical rule, right? Okay, so here's my empirical rule. This is 1 standard deviation, this is 2, this is 3, right? But what if we're not exactly at 1 standard deviation or 2 standard deviations? This one is 2.1, so it's like somewhere in here. Okay? So we're finding the z-score, which is how many standard deviations it is away, and then we can look up the percentages on the chart that I gave you. Not yet. We're going to do that in a minute. We're going to talk about percentages in a second. Okay? We're just going to find the z-scores next. Okay, so 42, if I'm looking at this equation right here, and I'm going to zoom in a little bit because this seems far away. I'm going to look at this equation right here. We've got x, mu, and the standard deviation. Where does 42 go? 42 is x.
Okay, so all these numbers are just going to end up with x,
Okay, 42.
right?
Yep, all of these are x. We won't always be given x, but in this case, those are all x. So I go 42 minus 46 divided by 2.8. So again, I'm going to stick that in the same thing. I like to hit that control divide again, so I get a fraction. 42 minus 46 divided by 2.8. This is negative 1.43 away. Okay. Why don't you guys try C on your own?
Okay.
So, what am I going to plug in 47 for? For which?
47 x.
Okay. And what is the mean again?
47.
And what is the standard deviation again?
2.8.
Okay, plug it in. Tell me what you guys get.
0.5.
47 minus 36 divided by 2.8 is 0.35. We okay? It's a little weird. Okay. Sorry, they're not, yeah, it wasn't supposed to be multiple choice. It was supposed to be different problems. Okay, now number 2, I'm going to switch it up. Number 2, I know the mean of a total miles ran last week by each member on the track team is 4, with a standard deviation of 1.2. We know that Clay's z-score is 2.5. How many miles did he run? So I don't know x in this case. But I know the mean, I know the standard deviation, and I know the z-score. So I know that we don't know what x is. We don't know what x is. So we have z, we have the mean, we have the standard deviation, we're looking for x. So sometimes writing them down helps. If we go 4 equals that mu thing, 2.5 equals my standard deviation, and I have z equals, 1.2, excuse me. Yeah, and I get 2.5. Now we have to solve it, right? So we can't, this is being divided, so what's the opposite of division?
Oh my goodness, I think I got it.
Good, what did you get?
7.
Yep.
Oh my goodness.
Okay, so I've got to multiply both sides by 1.2. Okay, these cancel. And I get x minus 4 equals 3. Because 2.5 times 1.2 is 3. And then I add 4 to both sides. And he ran 7 miles. Correct. And then I added, and they canceled because we got a 1.2 in the bottom. So 1.2 times x minus 4 divided by 1.2, those cancel out. And then I ended up with x minus 4 equals, x minus 4 equals 3. And then I added 4 to both sides.
This makes so much sense, doesn't it?
Yep. And then added the 4 to both sides. These cancel. 2.5 times 1.2 is 3. And then I get x equals 7. Okay. A set of test papers is normally distributed with a standard deviation of 5. If Riley scored an 83 with a z-score of negative 0.5, what is the mean? So we're going to go through because we have 4 different things, right, that we need to do the equation. So in this case, do we have z? What's z? It says z-score of negative.
Negative 0.8.
Okay. Do we have what x is, what he scored?
83.
Do we have the mean?
No.
Okay. Do we have the standard deviation?
Yes.
What's the standard deviation? 5. Okay. Now I'm going to plug this in. I've got 83 minus mu, we don't know, or you could put x down, it's fine, all over the standard deviation 5 equals negative 0.4. So the first thing I'm going to do is multiply both sides by 5, and I get 83 minus mu equals, so we go negative 0.4 times 5 gives me negative 2. Then I'm going to subtract 83 from both sides. Yep. Average, yeah. So 83, or the mean, is what I mean. We get negative 40. We're going to divide by a negative, and we get the average is 40.
Wait, what did you get?
I got 40.
Oh, wait.
It should be 83, excuse me. I switched it. It should be 85.
Wait, still no.
Okay. All right, so let's try this again. You guys got to, you know what? If you can't, Christian and Jamal, if you guys can't be quiet while I'm teaching, you can leave.
Oh, no.
Okay, yes, I'm going to just do the whole thing again. Okay, so we've got 83 minus mu over 5 equals negative 0.4. First thing I'm going to do is multiply both sides by 5. These 5 cancels. And we get 83 minus mu equals 85. Equals negative 2, excuse me. 5 and 5 cancel. Then I'm going to subtract 83 from both sides. And I get negative mu equals negative 85. Divide by a negative 1. And I get 85 is the average. Okay. Number 4. The height of a group of trees is normally distributed with a mean, so I already have my mean, 14.3. The z-score, so I have my z, is 20. Oh, is 1.9, excuse me. And my tree, so my actual number is 20, and I'm trying to find my standard deviation. So I'm going to go 20 minus 14.3 over standard deviation, which I don't know, equals 1.9. Okay. So for this one, you can think of this 1.9 over 1, and we're going to cross multiply. So if we go 20 minus 14.3, I get 5.7 equals 1.9 times my standard deviation. And then I'm just going to divide by 1.9.
You say you got
5.7? Okay. So 5.7 divided by 1.9 gives me 3.
You can just cross multiply.
Yeah, it's cross multiplying. You're timesing like this. So I get 5.7 times 1.9 times my standard deviation, divide by 1.9. I get my standard deviation is 3. You don't know what the standard deviation is, so that's my unknown. So I do 20 minus 14.3 is 5.7 times 1 is 5.7. I'm multiplying this times this, and then I'm multiplying this times this. Right, so that's why it's still there. It's 1.9 times that. Then I divide by 1.9. Okay, now we're going to use the chart that I gave you, that you were supposed to pick up. So we're on the back. The normal distribution in which the mean equals 0 and the standard deviation is 1. The distribution is standardized by the z-scores. Okay. So, we want to find the golf scores in a tournament is normally distributed with a mean of 76 and a standard deviation of 2.6. We're going to find the probability for these. So the first one is just looking at a z-score. Okay? The z-score is less than 2.1. So we're going to go to our chart right here. And I'm going to teach you how to read this chart. So I'm going to go to 2. And we want just 2.1. So 2.10 goes right next to it. 2.10 goes right next to it. This is 2.11, 2.12, and so on. So I go to 2.1, I get 0.9821. So that's the probability that x will be less than 2.1.
So it's a really high chance or really low chance? Like
High chance.
Okay.
Because we can move that over 2 places and it's a percentage.
Yeah.
I went to my chart. These are z-scores. And I went to 2.1 and I wrote it down. Yeah, you're going to need a bigger one. I'll blow it up for you, Abby. Yep. Yep. The next one is 2.11. The next one is 2.12. The next one is 2.13. Okay. All right. We want to know the probability of getting a 74, where x is less than 74. So we're going to go 74 minus 76 over 2.6. We're using the other side because we have to find the z-score. So we took the mean, which is 76. So we took the number minus the mean divided by the standard deviation. And I get negative 0.76. And then I take out my sheet, that's the z-score, and I'm looking up negative, so I go to the negative side, 0, and I want 0.7, and then I go over, so see how I'm right here? I'm at -0.07, and I'm going over to 6.
Where is the negative side?
It's on the left.
Oh.
So, negative 7.6. I'm going down 6 over -7. This is hard for me to read, so oftentimes I use a ruler.
Yeah, I can't see.
0.2236. 2236. So, this said Z. So I knew just to look it up. This one I have to find the Z in order to look it up. Okay. This is Z is greater than -1.5. Okay? So, I'm going to take my paper now. Does this have a Z in it? So I don't have to plug it into equation because I already have Z, correct? Okay. So now I'm going to take this. I'm going to go to -1, -1.5, and I get 0.0668. 0.0668. Because this is above, we have to go 1 minus that area. So I'm going to go 1 minus 0.0668 to get my probability. When it says Z is greater than, I have to go 1 minus it. What are you asking, honey?
Z
and I get 0.39332. So, do you get that I have z right here? It's given to me.
Yes.
Okay. Okay. So, hold on. I'm on z. These are my z-scores, correct? You're with me so far? I'm looking up negative 1.5. This number right here. The equation that we worked on this whole time. So, on this side right here, it's the equation we've been doing this whole time. Stop talking! So, we did x minus the mean divided by the standard deviation. We have the mean, we have the standard deviation, we have our point. So 74 minus 6 divided by 2.6 is negative 7.6, negative 0.76. Then we look, nope, because we're looking for the z-scores. We don't have to do anything like we did for the last ones. This is just like the first one, and then we find that. Okay.
Can you do that whenever it doesn't say z greater than or less than?
Yes. If it says z is less than, we can just look it up. Z is greater than, we have to do 1 minus that. Jamel? Number 8, it gives us x, so we have to plug it in. So we're plugging it into this equation, except instead of 74, we're going to put 81. So we're going to go 81 minus 76 divided by 2.6. 81, because that's the mean.
For all of these?
Yep. And I get the z-score is 1.92. Then I'm going to go to the z-score. Now this says x is greater than, so I'm going to have to do 1 minus whatever I find. So now I go 1.92, so I go to 1.92, which is 0.9726. 1 minus that gives me 0.0274. If it's greater, you minus it from 1. And it does say it right here at the bottom of your z-scores. To the area of the right of the z-score, 1 minus the area. Uh-huh. Okay. For these, I've got to find 2 things. Okay, I'm given z-scores. So I'm looking up on my paper negative 0.2. Which gives me 0.9641. And then I look up 1. Is that your phone? I look up 1.8. And that's 0.4207. And I'm just going to subtract them. Because I want to find in between. And that gives me 0.5434. You're just taking the bigger one minus the smaller one. Okay, 10's a little more complicated because I don't have a z-score. So I'm going to have to find 2 z-scores. So I'm going 77 minus 76 over 2.6. And I'm going to do 83 minus 76 over 2.6. Because I've got these 2. And I get 0.38 for this one. And 2.69 for this one. And then I plug it, and then I look up my z-scores. And for this, I get 0.9964. And for this one, I get 0.6480. And then I'm just going to subtract. 0.9964 minus 0.6480, which gives me 0.3484. No, not really.
So you would just get both of them?
Yeah. So I found both of these. These are my z-scores. I looked up both of my z-scores, and then I just subtracted them. Okay? So you've got your homework for tonight is to just practice those. Number 1 looks just like number 1. It's not, you're not picking A, B, or C for your homework for tonight. You're literally doing 3 different problems. Okay? All right, if you have any questions, please let me know. I am stopping recording this.